All right, what's up, Fourth Bell? Most of you are hard at work. Some of you are past this lesson. Some of you are not. And it's time for us to record our 5-minute lesson on symmetry. Many of you guys know a lot about symmetry, but few of you guys know anything about rotational symmetry. So this will be partially completely reviewed for you, and then we'll also be partially completely new. So reflectional symmetry is the symmetry that we are used to talking about. It's like, how do we draw a line through something so it's the same on both sides? So here's a vertical symmetry for this shape, but this shape also has a horizontal line of symmetry. Rotational symmetry is when an image is mapped on itself after rotating less than 360 degrees. So there's 2 students in here that already did their part 2 take home to unit 3, and I gave them full credit on their letters of rotation. They said every letter has rotational symmetry. Just rotate it 360 degrees, 720 degrees, 980 degrees, and I counted that right for them because I had never stated this fact, that in order for a shape to have rotational symmetry, it's got to be able to rotate less than 360 degrees. So notice, if I took this one right here, if I rotated 180 degrees, it would look just like this. So that does have rotational symmetry. So let's look at some other examples. Let's look at this one. Does figure A have reflectional symmetry? Sure it does. It's got a horizontal one. It's got a vertical one. What is the rotational symmetry for A? 180 degrees. Okay. Now, does figure B have reflectional symmetry? I don't think it does. The arrows will be pointing the wrong way if you were to try to reflect that vertically. Now you're going to have an up arrow on the left and a down arrow on the right, and that's not going to be the same. So there is no reflectional symmetry on this one. But what about rotational symmetry? It does. If you rotated that 180 degrees, you would get a shape that looked like this. It's true. So it does have rotational symmetry. It does not have reflectional symmetry. Let's keep, oh no. Let's keep looking. How many lines of symmetry does a hexagon have? 3 through the vertices and 3 through the midpoints. So there are 6. Envisioning this is how we start to 6 or 7. I think it's just 6 people. I think it's just 6, Caden. See, I can say it when there's meaning. I'm not going to repeat a meaningless statement, and I appreciate you having that conversation with me on Friday. Okay? So there are exactly 6, less than 7, more than 5. Shake your hands. Now, how can we use that to think about rotational symmetry? Well, here's what you do with rotational symmetry. First of all, it needs to be regular in order to have rotational symmetry. Think about a circle. How many degrees are there in a circle? There are 360. So all of these points are equally spaced out on the circle, right? How many points are on that circle? Because it was a hexagon. 6. Now, what is 360 divided by 6? You don't need to know that. What is 360 divided by? It's 60, right? 60 here, 60 here, 60 here, 60 here, 60 here, and 60 there. So, if I rotated this hexagon, how many degrees? It would look exactly how it currently looks, 60. And so that means the rotational symmetry for a hexagon is 60, 120, 180, 240, and 300. It is 360, but we don't say that one. You hear me, Leela? You hear me, Sienna? Sorry, I didn't make that clear when you guys were taking your test, which is why I didn't mark it wrong. Seems fair to me. Got it? Okay. Boink. I think this might be one more slide. Oh, this one's fun. So now it's like, oh, well, that's not a shape. How am I going to do that one? Make it into a shape. So hopefully you guys are able to identify the reflectional symmetry. They are 1, 2, 3, 4. There are 5 lines of reflectional symmetry for that one. But for rotational symmetry, just do this. Connect the endpoints. What shape does that look like? Pentagon. Draw a circle around it. How many degrees is a circle? How many sides do we have that are equal? So 360 divided by 5 is, it's right there. They're doing it for us right next to it, 72 degrees. So every 72 degrees, every time this point goes 72 degrees that way, the flower looks exactly like it used to. So our rotational symmetries are 72, 144, 216, and 288. Boom!